I bought this Ender 3 version 2 3D printer about a year ago. Bought it originally to make some PLA patterns for metal casting that I'm planning on doing, and I wanted to be able to create something in software like Fusion360, transfer it to a slicer that helps to make the path for printing for the 3D printer, and then I was going to print it out on this. But recently we had a part break on a drill press at work, and it's just a little plastic piece. It's not a high-end drill press, it's just for making holes in thin gauge steel or in wood. So this is a little depth stop mount, and it broke. I don't know if you can see it, but it broke here and here. And I figured, well, we can replace it, but why not see if I can print it? It gave me a challenge to see how accurate I could get. I ended up printing it on this like flimsy stuff right here is called a brim, and it's what helps to adhere this to the plate of the 3D printer. But this is about a $300 3D printer made by Creality. It's a pretty popular brand and a pretty popular model, the Ender 3 version 2. And I'm just going to show you a quick workflow on how to go from a broken part to a printed part. One of the first things you're going to want to do when you're making a part like this is you might want to even do it with a piece of paper, writing down, but you're going to want some accurate sizes. When you're printing in 3D printing, you're going to normally be printing in millimeters. So you're going to want to find as much as you can in millimeters on this part. So what you do is you're going to need something like this. I mean, you can just get a metric ruler like this, and kind of it'll be okay. Obviously this one says centimeters, so for those of us who usually measure in inches, there's 10 centimeters. 10 millimeters in a centimeter. So those little ticks right there are millimeters between the 1 and the 2 and the 3. So you can get by, measuring a part, with one of these, but it's a lot easier to use a digital, I guess it's called a micrometer or digital calipers. You can buy these online. This thing cost me about $25-30. Stainless steel, and it's okay. It has pretty good reviews on Amazon. We're talking about parts like this. We're not talking about medical equipment or some sort of really high-end racing equipment or anything. So I'm okay with a $30 micrometer, but it's gonna be tough for me to do this while I'm holding. But you're gonna just put this on here, and you're going to just get measurements. You're going to get the measurement of the diameter of this circle here. You're going to get the measurement of I'm trying to do this with a hand on there. You're going to get that measurement. You're gonna just take a piece of paper and just start writing down and do a little sketch of this, and then make the measurements. And then you're going to go into a program like Fusion, and you're going to you have to know how to use Fusion, so I'd recommend looking at some tutorials. But Fusion, Tinkercad, I would stay away from something like SketchUp. That doesn't really work very well for 3D printing unless you have the Pro version that makes a more watertight model. But I'll bring up the model of this so you can see an example. Okay, so I modeled this in Fusion And it transfers really well to 3D prints. You want to have it in your preferences. You want to have the units in millimeters, so it's exporting an STL format. That's what I export, at least, to 3D printing. You can export some other file formats. I think OBJ is one, but you want to export something that's, you know, gonna translate well to the next stage of this. But, you know, I like what I was showing you with the calipers. You know, I measured from here to here, so I knew the diameter of this circle. Then I added it all kind of in this. You can kind of just draw it out with these drawing tools right here. You know, I used this one, and trust me, this is the engineers are going to be shaking their heads, because I wasn't using a lot of constraints or anything like that. I was just trying to make this quick part. So I was trying to make it quick and dirty just to see if it'd print out, and it did. I'm still learning Fusion 360, so I'm not going to pretend to be the guy to learn Fusion 360 from. You just try to find something like Tinkercad or some CAD-based program that can export an STL to the next step. So what I did was I went up here and I exported it. I'm going to show you. You export it. You can hit this 3D print one too, but I export it as an STL, and then it shows you know, what you're going to choose, and then you just scroll down to STL and then choose that. You name it something, and then you export it. Okay, and then I'll show you the next step. Okay, so the next step is to open up something. It's called a slicer, and the slicer takes your STL file that you just made in your CAD program, and it basically slices it down and tells the 3D printer via a new code called G code. It tells it how many layers it needs to be. So I'm gonna click on Cura, and this is the beta of the beta of version 5. And what you're gonna see, if you have it, once you have it selected for your printer, you're gonna see kind of a representative of what your 3D printer looks like. And then you're gonna open up the file, and then I'm going to go to the newest STL that I have. So I have drill press stop STL, and then you open that, and it's going to show. And for some reason, it always seems to make it vertical like this. But what I do is I'll select the model, come over to here. First, I'm going to check, make sure that the millimeters and the y-axis and everything is kind of along the lines of what I had in Fusion, which it is. And then I'm going to rotate this. So I'm going to come over here and I'm going to rotate this guy around 90 degrees. Whoa, too much. And it'll automatically set it on the bed, so it's not going to just keep it floating there. Okay? And then, you know, there's different settings, and I'm not going to tell you how to put your settings. I had a very low quality print because I was just seeing if it was all gonna work out, because I had some bad prints prior to this. So I chose a low quality so it would get done quicker. But then I go down here and I hit slice, and it slices it. And then I'll go up to preview here, and it'll show me what this is going to look like once it's printed. And I can use this slider, this little slider on the right here, and I can move it, and it'll show me the layers. It looks like it's melting, but it's actually going from the very bottom of the bed here, and then it'll slowly go up and show you how it all those paths for the extruder. Okay, and then since it's all sliced, you save that to a removable drive, which the Ender works well with a little micro SD. So I'll save that to my USB drive and then come over here and it'll save it to this little fella right here. See if you can see that. And then I'm gonna just put this into my Ender 3. And then I'll go into the menu here and choose print the file that this was, which is CE3 Pro, and I'll select that, and then it'll just start printing. And this is what ended up printing. This one is low quality. It has supports built into it. Well, you see, you can't really see that real well, but that's a logo, like a hex head, for a hex head bolt to go through all the way. You just knock that support out at the end of the print, and everything lined up pretty well. I mean, my measurements were pretty good. It's hard to tell because you can see the brim. The brim is still sticking on the bottom. That's the thing that helps to just hold the print down to the bed. But it printed out pretty darn good, and I'm anxious to try it out. And I don't know if this will help or not, but it certainly is kind of the process that you can expect when you're first getting into making parts. If you just don't want to make a I don't know, a Pikachu little gadget or something like that, if you want to use your 3D printer to make some parts for your shop. Thanks for watching.